Now, in this video, we're going to take a look at some of the questions from this worksheet, graph and trig functions relevant to the cosecant and secant, I guess, as well. So we got things like constructing the graphs, okay, and asking some questions relevant about them. Okay, so let's go back. Let's go back to Desmos. Take a look at the relevance of how secant came to be. Now here is the graph, the item that we had. Here's the graph of the cosecant function, okay, which is, as we said before, the backbone graph of the sine graph. So there's the sine graph. Take it away. Here's the cosecant graph. So you need to construct the sine graph before you can construct a cosecant graph. All right, and you need to incorporate in the sine graph any period changes and phase shifts. Okay, so if a cosecant or secant function involves the A, B, C, D values, okay, you first have got to incorporate the B and C into the sine function. That would be the period alteration and the phase shift into the sine function, and then get the sine function backbone graph, okay, and then go and construct the cosecant, and of course A would change the more or less the range of the function, because as you can see here, if I played with A, of course we've seen that before, okay, that we change the range. In other words, we open up that gap of no graphing there, okay, with values of A. Of course we could flip it over too with negative values of A. And D, of course, is just going to shift it up or down, which my suggestion is you just go and shift the axes rather than the function. Okay, so the cosecant is 1 over the sine, so wherever the sine is 0, the asymptotes of the cosecant occur. Okay, wherever the sine is 0, the asymptotes of the cosecant occur. And of course, if we're looking at the secant graphs, now I think we had some questions relevant to that. Let's go back and ask some of those questions, okay? So let me start with some of the questions here relevant to secant and cosecant, and see if we can answer some of those, okay? All right, it's the wrong exercise. Let's see, here it is. Okay, so here we go. Find all asymptotes of the cosecant. Well, again, remember that the cosecant is 1 over the sine, and so wherever the sine is going to go to 0, there's going to be asymptotes there. So that's going to be at pi k values, okay, at all pi k values. That's because remember what the sine graph looks like. 0, pi, 2 pi are all the intercepts, so wherever those intercepts are going to occur, that's where the asymptotes are going to be. What is the solutions to the equation secant of x equaling -1? Okay, well again, the secant is 1 over the cosine, okay, 1 over the cosine. Now remembering what the cosine graph looks like. Okay, so wherever the cosine strikes -1, that's where the secant is going to be -1 there, right there. So that's going to be at pi, and then of course all values down the line. So I guess we're saying x equals pi plus 2 pi k. All right. Determine the phase shift for the function. Okay. Well, again, the phase shift here is going to be the same as the phase shift of the cosine of 4x minus pi over 2, which is going to be your opposite of your c over b value. Okay, I guess we'll put that as minus plus. That's usually how I indicated that. Okay, so then that would be what? Negative, it would be pi over 2 divided by 4. So I guess divided by 4, which is times 1/4, which is pi over 8 to the right, is going to be the phase shift of that guy. Okay. Let's see what else we got here. Find the range of this. Okay. Well, then the range pretty much offset right there. It's from negative infinity to negative 1/2. And then I guess we can include that in union with 1/2 to infinity. All right. Find all solutions to cosecant x equals -2. Well, that's all the solutions to 1 over sine of x equaling -2, which is the same thing as the sine of x equaling 1/2 negative, which is occurring at reference values of pi over 6 in the second, rather the third and the fourth quadrant. So I guess it's 7 pi over 6 plus 2 pi k and 11 pi over 6. Sorry, 11 pi over 6, yeah. 11 pi over 6 and all plus 2 pi k's. Okay, so let's see what else. Phase shift there, same with what we discussed. Let's this is just an equation. Of course, you're gonna solve that by I'd say divide by 3, and then you've got this looks like it's going to have no solution, because you're going to have, if you divide by 3, you have the secant equaling 1/3, and that's just never going to happen. The secant is never going to equal 1/3, so nothing to do there. Okay, that's the same as saying when is the cosine going to equal 3? So there's nothing really to do there. So now let's look at some of the graphs. Okay, let's look at how we can construct some of the graphs. The graphs, let's do, this is a cosecant. Okay, so that's a cosecant graph. So this is, it's not going to be that bad, because this is the period is 2 pi over 2, which the period is pi, and the phase shift is pi over 2 to the right. So what I want to do is I want to graph the sine of 2x minus pi. All right, so let's get that graph back going. That's the backbone graph. Okay, and again, it's just a sine graph. So sine graph is just always like that. Of course, now I can come back and put in my values, because the period is going to span pi. So this period is going to span pi. So there's going to be my pi over 2 value. Okay, and then I can put it back another wavelength here. So that'd be back to negative pi. All right, but now I've got this thing out of phase, so actually I'm going to come and let's just change the color on that, make it easier. Okay, so actually I'm pi over 2 to the right. Okay, pi over 2 to the right with the phase shift. Okay, so then I'm moving this point to here. Okay, and then I'll just get my graph going like that, I guess. Okay, so now here's my here I'm going to come and I'm going to erase this guy. Okay, all right, and then come back and get this graph going. Here we go. Okay, so here's one wavelength spanning to pi. This would be down here 3 pi over 2. Okay, and now I've got a negative, so I'm going to come and build my secant graph from there. My asymptotes are going to be lined up here. Let's put them in black maybe, and then here comes my asymptotes. Wherever the sine backbone graph intercepted the axes is where this thing is going to have its asymptotes. And so this is going to be with a -2. So if it were 2, it'd be up here. So it's -2. It's going to be down here. It's going to be graphed and ride those asymptotes. It's going to be up here at 2 and ride those asymptotes, and so on and so forth. Okay. And then that should be pretty much that graph. I can come and actually, at this point, if I want, I can erase this. And there's my graph of that function of the secant. Okay, so there's some questions answered. Let's see what if there's anything else here. It's secant, cosecant relevant. That here, much the same. If you wanted to shift it up 3, what I would do is rather than pull everything up, I would just pull the axes down. This makes it a little easier. Okay, so there's your assessment of things on the secant and cosecant. What do you say? What is the range of this guy again? This is right here is going to help you determine that range. So it's everything from negative infinity to a -1/4, and then from a +1/4 on up. Okay. Hopefully that helped, and you were able to get through those exercises, and with the help of this video. Okay, that's it.